This video shows how Backpocket Questions are a strong talk move to use with small groups. These 3 rounds of questions can be used anytime to have students focus on deepening their explanations about what they're seeing. Talk, task, and tools play critical roles in helping students engage in intellectual work in this classroom. As you watch, pay attention to how tasks are designed to help students move from simply making observations to hypothesizing about unobservable events. What tools help students communicate their thinking, and particularly how talk moves facilitate students hypothesizing about causal mechanisms. This classroom example used for the video comes from a 7th grade class. They were collecting evidence to answer the unit question, why does yeast decompose organic matter? Eventually, students would come to understand that fungi use cellular respiration to generate energy from sugars, and they use this energy chiefly for reproduction. The clips shown in this video are from days 4 and 5 of the unit, where students are observing a yeast, starch, and water solution covered by a balloon and reasoning about why the balloon inflated slightly and where the gas could have come from. In today's activity, students are adding to their list of observations and also sharing inferences that have been made about how and why they think the balloon inflated. In the next clip, the teacher shares the focus questions with students before going to lab groups.
And I also want you to think about a couple things too as you're taking your observations. What are the things you're starting off with in this setup here? You might want to think about some of the things you can't even see either. Why didn't your balloon get bigger? If it stayed the same, it looks like they're pretty much the same. Why didn't it get bigger when it gets to time? And the last question is, why is the balloon even inflated at all? So think about these 3 questions as you're recording new observations and making any new inferences for yourself. Any questions?
Backpocket questions are designed to help students reason about their observations and make connections to larger science ideas. There are 3 steps to using backpocket questions. First, start with observations. Focus students on making and sharing observations and patterns about relevant parts of the model. Next, pose a how or why question to get students to explain the cause of their observation. Finally, leave the group with a question to discuss or task to complete that will help them further reason about something unobservable. As you watch the following video clip of a teacher talking with a small group, note how she follows the 3 rounds of questioning.
Anything different for you guys today?
It kind of
Kind of what?
yeah, and it kind of turned a bright yellow.
Okay, so we've got some color changes maybe.
It looks like the yeast is on the bottom.
You think maybe the yeast is on the bottom? We guys, everyone agree on that?
Yeah,
Why do you think it's on the bottom?
because it's heavy within the water.
Maybe that when the water's hot, it raises it up.
What raises it up?
The yeast.
Oh, the yeast is rising?
Or there's more water pressure or something.
Oh, in here?
Yeah.
What about your balloon? Did it change at all?
Not much.
No. How long did it take for your balloon to get inflated like that?
5 minutes, 10 minutes.
5 to 10 minutes. So what's the difference between before, like when it was inflated, and after? Where's that gas coming from?
we kind of thought it might have been the warm water, like the steam out of it rising.
Oh, okay. So, but then how come that didn't just happen right away? If it was the warmest, right when you pour the water into there, and then you put the balloon right on top, shouldn't it have just inflated right away then?
Well, no, because the steam might have to like escape out of all the heavier stuff that's on top of it.
So you're saying that there's air inside of here?
Kind of, yeah.
Kind of? What do you guys think? Yeah?
Yeah.
Maybe? Well, feel it today. Does it feel warm to you?
No.
So then if there's no warmth, what do you think should happen to that balloon? If you're kind of going with that idea.
Probably deflate.
It would deflate, but it's not deflated, so you think that gas is maybe coming from something else?
No, because once the air
warm
got in there, since it's sealed, it can't come out, so it'll just stay like that.
Because the warm air always rises and always rises, so.
But then what happens after it's not warm anymore?
there's always like there's probably still warm air up in the balloon.
Well, we're going to talk about that more. I want you guys to think more about maybe like, is there maybe another place that air can come from besides just the fact that there's warm, maybe it's being warmed up?
Maybe at the yeast is on the top, or
Talk about it. Where else can the yeast be, or the air come from?
The yeast. Ow.
I don't know. It's only other place.
This kind of.
Maybe it has something to do when the yeast mixes with the water.
In the next clip, with a different group of students, the teacher still moves through 3 rounds of questions, but the talk is not identical to the first group because she listens and responds to student thinking.
So you saw some bubbles. You make sure you share that out with the class today too when we're talking about the observations. Right? Anything else that you?
well, we were looking at how it's separated. We all kind of noticed that right away.
Yeah. What do you think those separations are made up of?
I'd say the water and like the cornstarch.
Oh, the starch that I use. Yeah. Possibly. What about the yeast? Where does the yeast kind of fit in? Does it fit in there?
It could be kind of mixed. I don't know.
Mushed up or mixed up in there. So what are you guys saying about this air that's in here? Where's that coming from? You can read your inferences. Like I said, you guys all can have different ones here. Let's start off with Drew. What do you have?
Well, for my inferences, I said the yeast will slowly rise, filling up the balloon.
Okay. The yeast is bubbling up. So you're saying the yeast is inside of this balloon right here? You cut it open and you see some yeast, maybe?
Maybe, but I think like when the yeast was pushing up, it was pushing like the air into the balloon.
Oh, so this amount of air here is being pushed here? Yeah. So you think that if we let this sit for longer, you don't think that balloon will get bigger? No. But how come when you put everything in there, like let's say you put the water and the starch and the yeast in there, and you put the balloon on right away, did you see it inflate right away?
Not really. It took like a minute for it to start getting a little bit bigger.
Okay, so is there maybe another explanation for where that air is coming from besides maybe being pushed into it? Can air be coming from somewhere else? What do you have?
I think the air, whatever it is coming from the yeast making some sort of reaction with the starch and water.
So it's making some kind of a reaction. So you're saying the yeast is making that?
Because you put yeast in bread to make it rise, and it kind of puts little air pockets in the bread, so sort of like that.
Great, and you know what, make sure you share that one with the class too, because that's a great example. And are you guys kind of focusing on what are some things that maybe you start off with that maybe you can't see that we put together here?
The purpose of Backpocket Questions is to push student thinking about a particular observation to make connections between the observable and unobservable. During their lab experience, the teacher gives students time to think, talk, and make notes to try to make sense of their observations, rather than simply telling students how and why the yeast inflated the balloon. Listening to student thinking is a critical move because their ideas inform her subsequent teaching. For example, based on this use of Backpocket Questions, she heard some students positing that the inflation was just like baking soda and vinegar. So her warm-up question the following lesson was, how is the yeast experiment we did yesterday different from doing one with baking soda and vinegar? To help students move towards the metabolic and biochemical reaction portion of the explanation they were missing on the day. Let's revisit 3 rounds of Backpocket Questions. First, focus students' attention on important observable aspects of the activity or model. Then, ask students to hypothesize about their possible causes. Finally, leave the group with a question or task to help them further reason about the activity. Talk moves like Backpocket Questions require the use of a model or activity as the focus for observations to help students construct pieces of a larger scientific explanation, which is part of the next generation science standard.